Dziękuję bardzo. Za chwilę przełączę się na język angielski. Moja prezentacja jest w angielskim, ale można też spokojnie zadawać pytania w polskim. Przepraszam, że może tak w angielskim. Wiedziałem, że część audytorii po prostu wyszła. No. Dobra, let's start. Probably for the beginning, who have ever used Jira before, earlier? Oh, okay, so you're right people. Joking. Very nice, I can recognize some faces here whom I know, so my built-in face recognition system. Looking forward to talk to you after this presentation. My name is Lutsiv. I'm currently development manager at Spartus, and I work with Jira Cloud teams for Atlassian, so I actually used Atlassian template for this presentation. What Jira Cloud teams do here in Gdansk, we run Jira in production. We work on new Jira user experience. It is currently being rolled out to all our customers, and one of our teams actually work on performance at scale topics. So I'll be mostly talking about that today. So first, let me start with some history. I'm proud to announce that right now Jira Cloud is a truly software service application backed by AWS. So we fully run from AWS. That was not true like before New Year, last year. We had a big internal project called Vertigo. When we actually migrated from architecture when there was a single Jira instance serving a single customer to real multi-tenant architecture when a single Jira instance can actually serve multiple customers. All of that work was done in production without any interruption to our customers, I hope so. So actually what we did, we migrated from server to cloud. When Jira Cloud was actually started a few years ago, it was like, I would say easy. It was not easy, but obvious solution for us. We took Jira Server, installed it on hardware on our server, and gave it as a cloud solution to our customers. So every new customer coming to us to cloud was actually getting a dedicated server. We were installing Jira Server there and pretending it's cloud solution. We actually understood from the very beginning it would not scale, so we had to rework that. And now, these days, we're actually running from AWS. We scale as we need. We are multi-tenant. We're using a lot of AWS services. We run Jira in few regions of AWS in multiple availability zones. And actually, all of these transformations highlighted few benefits and problems that I'm going to talk about. So let's start from benefits, it's easier. Scalability. Now in AWS we can easily scale horizontally and vertically. Horizontal actually means deployment and start rollout of new versions. We just add more servers, deploy new versions there, and then remove servers on all versions. We also do a lot of experimentation with vertical scaling, like we experiment with instances size. For some kind of task we need more powerful instances, for other tasks we can use smaller instances. Fast deployment. Year ago, some people here can confirm that, we were deploying more or less like once per 1-2 weeks. Now we can actually deploy every hour. And that's a major shift for us because every change now, so it's a big paradigm change for our developers because what I put into master now can be in production in a few hours. So every change is actually behind a feature flag. So when we roll our code change to production, we actually control when they will be served to our customers using a feature flag. So I'll talk about that a bit later. And this frequent deployments also guarantees that we deploy, because we deploy more frequently, we actually deploy smaller amount of changes. So we can easily detect when the problem was introduced and what change introduced it. And reliability, because previously you can imagine we were running hundreds of thousands of servers. Any server can go down, and effectively customer can no longer use Jira instance. Now if single or even few servers in AWS go down, we even do not notice that because we add more servers with our auto-scaling rules. And you can imagine how easier it is managing hundreds of servers except of 100,000 servers. So we actually reduced complexity of our system significantly. Now challenges, more interesting part. Cache. So previously, because we had single Jira per server, we could actually cache everything into memory. It was cheap, it was easy, it was fast. When we actually moved to real multi-tenant architecture, we can no longer do that because every Jira instance can now serve requests from thousands of clients. If you try to keep all of that information on a node, you'll run out of memory first, and second, on every next request, your request may go to a different node that doesn't have a cache, so that request will be really slow. If you think about, okay, let's use external cache, for example, memcache. Yeah, fine, but to access memcache, you should go through a network. Network adds a penalty, it's long, so like now using a cache costs you additional time. So what we actually did, we removed caches completely. Except one thing that we use per request caching. So if within a single request we are going to need some data more than once, we are going to cache the data just for that single request and then reuse it. Such architecture also helps us avoid some problems like, for example, cross-customer or cross-tenant data leakage. Because if you cache data intensively, there is a huge risk some data will be accessed by the customers who should not have access to it. Next thing, database. With such architecture, database storage, any database storage, not necessarily database, we are in particular using Postgres, can become a bottleneck. Because now thousands of customers or tenants use the same database. So in case if you have an inefficient query, actually few really inefficient queries can kill your database. It stops serving the requests for all other customers suffering from high CPU load and so on. So fortunately enough, Postgres that we use allows you to scale if you design your queries correctly. So what we really need to do, we need to think about correct database structures, adding indexes, things like that. Now we are addressing, after we moved from server to cloud, we're still addressing a lot of database problems, for example, N+1 problems. I will give you some real-world example. For example, for those who use Jira, you know there is a workflow list somewhere along an admin screens. And on that screen, we actually show workflow name. And one of the fields we show is about when the last time workflow was modified. So funny enough, we store most of the fields in separate database table, but this field, like when workflow was last time modified, lives inside workflow XML file. So in order to show information about modification time on the page, we were loading all the workflows. So let's say you have thousands of them. And then to show just that one single field, we had to load workflow XML, parse it, get the date to show it on the screen. So we were loading all 1,000 workflows once, and after that we were doing 1,000 additional database requests just to show one field. You can imagine that wrong. Typically that is fixed by fixing your database structure and storing information you need in the database directly. And again, that's a problem of server, because in server all this information was cached. So you loaded workflows, all of them are in memory, you access information easily. In cloud we cannot do that. And yeah, pay special attention to database load, because as I said, database suffers from a load. All customers residing in that database will suffer from performance problems. Even if you write a perfect code, there will be always corner cases. And single corner case can generate a query that will run for seconds or even tens of seconds. And it will cause problem for the entire shard, for the large group of customers, thousands of customers. So that's why we really pay a lot of attention to rate limiting, and we have different flavors of rate limiting in Jira. For example, we can rate limit specific URLs per client, or we can limit number of requests from particular client, or we can limit number of connections on database from a particular client, or we can limit number of slow requests from particular client. So if, for example, some request is really problematic for us and it kills our infrastructure, we'll just rate limit it. That means some limited functionality to our customers. We'll fix the problem and we'll restore the functionality. It's how it works for us. Okay, I want to drink some water, sorry. In next few slides, I'm going to let you feel some Jira-ness, so I'm getting closer to scale topic. We love such animations with strange Godzillas moving around. Almost every our presentation has image like that. Okay, so some big Jira Cloud instances. I'm really talking not about single instance and this data constantly changed. I grabbed the data from our Splunk system last Thursday, if I'm not mistaken. So, for those who use Jira, you probably know issue type. So it's bug, task, story. Please imagine some customer has 1,100 more ideas to different issue types. I did not check what is that, but it sounds crazy. Custom fields, almost 2,000 on the biggest instance. 4,500 projects. Can't imagine what people track. Yeah, we have one very specific customer that has a task that has 22,000 subtasks. I'll not tell you what they are doing, but joking. And the biggest instance so far, but it keeps growing, has almost 2.5 million issues. So why I'm giving you these numbers, I'm trying to come to the main topic of this presentation, scalability. So as data volume grows, as Jira instances size grow, it's naturally that performance of those instances degrade. So performance itself actually talks about response times, how fast or slow your application is for the user. Scalability instead talks about how this performance changes when the underlying data shape change. And actually in Jira it was a big topic for us. Okay, we are now in cloud. Bigger customers will be coming to us. What do we do with them? How do we learn that Jira Cloud actually scales for bigger customers? So these are actually 4 steps we define for ourselves, how we deal with those biggest customers. So I'll go step by step. Cohort. So know your cohort, it's how I call. First, you should definitely know, it's all about Jira, but I believe you can use it for your products, applications as well. You should know your product behavior. So what are really the most frequent user interactions? You should first optimize towards optimizing, sorry for repeating myself, those most used user actions. For example, for Jira, that's queue issue, issue navigator, or searching issues and boards. Then you should think what are actually your scaling dimensions. So what are underlying data that grow as your Jira instances in this particular case grow. So I show you a few examples. In our case, it's user space, issues, projects, boards, custom fields, whatever. And then define a cohort. So what specific so as I said, with scale, performance will degrade as the instance grows. So how are you going to segment or define cohorts for your instances to compare them? We, in Jira, define that on monthly active users. So we believe that more users Jira instance has, more issues, workflows, projects, those users will generate. So we actually define some threshold for us and said, okay, some instances, we call them enterprise because they are big enough by number of users. Other instances are smaller, we call them non-enterprise. And we now compare enterprise instances to non-enterprise instances. Okay, so now let's say we define cohort. We have two, enterprise, non-enterprise. We actually need to look at some metrics. In Jira, we really love measuring user interactions because we believe that's what indicates perceived user performance. And main metric we use right now is ready for user. So it's when page is loaded, it looks like you can interact with it, but in fact, some actions become available a bit later. That's actually second time ready for interaction when page is fully loaded and all actions are available for you. Fully loaded, it's like everything is available, all additional functionality loaded, things like that. This metric is actually, we believe, is most representative for measuring performance, but this metric doesn't come for free because you should know exactly in your page when every specific interaction ended, when your page loaded, when all JavaScript's loaded, when every element is available for editing. That's why let's say honestly, we do not have 100% RFQ coverage in Jira right now. That's why we also use our server metrics, because every application has logs. In every application you have, in every log you can find information about response time. So we're looking at response times as well. We sometimes instrument our code to add some code timers, how a particular piece of code is executed. We log time spent in cache. We log information about how frequently we hit some cache. You can go in further and use even more specific metrics as an input for scalability factor calculation. For example, database metrics. I'll not stop here, saving some time. Okay, now, this is still work in progress for us. This whole topic is relatively new, but what we are doing now, so for every action, as action you can think about ready for user time or server response time, we actually calculate scalability factor, and that's how we do it. So let me explain. Y is actually P90 RFQ time for enterprise cohort. I explained to you earlier. X is the same RFQ time for non-enterprise cohort. And now we compare them. So one metric actually says we divide X by 1. So it actually says how slower are requests for enterprise customers comparing to non-enterprise customers. Second metric gives you an absolute difference. Because, you know, for example, some page may load within 1 second for non-enterprise cohort. For enterprise, they load 2 seconds. Both response times are still acceptable, but for enterprise, it's 2 times slower. And there may be another page that loads like 4 seconds for non-enterprise customer, and now it's 2 times slower for enterprise, 8 seconds. What page do you think will fix first? Definitely the one that regresses to 8 seconds, not the one that regresses to seconds. So actually, these 2 metrics we are now using for prioritizing work of our team. We look at all requests we have, we look at those 2 metrics, and we say, okay, we are going to fix this endpoint or this page next. If first per action metric is ideal for our teamwork prioritization, we will also think, okay, how can we define our longer term goal or the metrics that can be reported to top management or the metrics that we can share with our customers? And that's when we started calculating this aggregated metric. Sorry for a wall of text, but it was really complicated to put this information here. So if you ever want to calculate that, sharing our experience with you. So we calculate our aggregated metric as weighted scalability. Okay, I'll not be reading that, I'll just explain that to you. So SF stands for scalability factor. We take scalability factor for every action, multiply it by number of requests for that action. And then we repeat the same for every single action we have. And then we divide that, so in denominator, we actually just sum up all of the requests. So it will give you average. But you know, as usual, there are some fluctuations from week to week, from day to day. One day there were more requests to one page, another day it's more requests to another page. So we actually put some limitations here. We say this scalability factor, for example, if for some reasons it exceeds 1, or it exceeds 0, like it becomes negative value, we actually cap them, so limit them to our target value. So for example, if some page one day decided it will behave better for enterprise customers than for non-enterprise, that may happen of different reasons. Because, for example, low number of requests for enterprise customers those days, because there was some day off in the US, for example, then we just, let's say, ignore such noise, and then metrics become much more resilient to different noise signals. So that's how we calculate our metrics. When you have a metric, it's good, but how do you learn from it? So we do analysis. Let me explain. So all of the data I was explaining, we are actually taking from 2 systems we have. We use Splunk. In Splunk, we have all real-time data, really real-time. Like you hit some requests and a second later it's in Splunk. We keep data there for 2 weeks, and we use Datadog for aggregated data, so we can check our historical usage. With scalability metrics, the trick is, if you look at it like today, you can hardly make any conclusions. What really matters if you compare it from week to week. So how does the scalability change from yesterday to today? We actually monitor it weekly. And using that metric, you can actually predict your future. So you can now see how fast or how slow you improve your scalability. Actually, we cheat a bit here because we also have some data for our biggest server customers who decided to share such data with us. So we know what data shape we may expect for real big instances, and we kind of already proactively prepare cloud for such situations. So all of that is work to prioritize our work. That was the main part of this presentation. But when we touch Jira, that is quite old project that we moved to cloud, that has a lot of scary places inside, we are always not sure. So the change we did, will it improve performance or probably degrade performance because we missed something? And definitely we are afraid of incidents in production that will impact our customers. That's why actually our strategy is to deal with incidents. The best way to deal with incidents is to prevent it. So as I told you already, we are using feature flag rollout, that every change we roll out to production is hidden behind the feature flag. And we actually, what we do, so the code is there in production, we then start flipping on feature flag. We enable new functionality for 1% of customers, 5% of customers, 50, 100, and monitor at every step what we do. I was thinking about how to show you what kind of monitoring dashboards we have. So sorry, it's probably not that readable, but here is our Splunk monitoring dashboard example. So I took this screenshot for one of our known systems, ecosystem at lesson.net, that is used by our vendors. These are data for last 60 minutes, sometime previous week. For example, during that time, that was at night, so don't be scared about numbers. There were only 15 requests. We could easily know what was the minimum request duration, what was medium, what was P90, P99. For every particular request, we could easily see what was the response time of that request, how many Tomcat threads we used, what was number of database calls, what was query runtime, what was the percentage of time we spent in database. So all of that information is available immediately. And for example, our site reliability team, who is running Jira in production, have all of that under their fingers, so they can check data immediately when they suspect there may be something wrong happening in production. A few more examples. So I mentioned cache. Actually, those are second and third part of the same dashboard. It just did not fit into one screen. For example, we have all information about our caches. How frequently cache was hit. So actually, cache with a single hit is kind of suspicious. Why do we need cache? Then we have response time for caches, all different percentiles and things like that, and performance probes. I was talking about that we can instrument some pieces of code and see how long we spend in that piece of code. So that information as well. Generally, that's it. Thanks a lot for attention. Small advertisement. If you would like to join any of the teams working on the things I just described, you can check opportunities on our website. Thanks a lot.